All right, I guess I'm going to just jump right into it here. So I am CJ Montano. I'm the head of technology at Forte Group, which is a services firm. And I guess it's my obligation to come on stage here and really kind of just talk a little bit. But what I want to do here today is talk a little bit about this fine group of people that I have behind me. So as the head of technology at a services firm, especially one sponsoring, this is my little sales pitch, what is it that we actually do in terms of innovation? Well, one of the things that I like to say to anybody that will listen is we have to innovate through our clients. And I couldn't be prouder or happier than the fact that, in taking from what Alex said in his opening speech this morning, talking about constantly challenging yourself and constantly learning, we, Forte Group, partner with a company called Truebit, which I'll let Blane introduce in a second here, regarding Web3 and the verification space and all of the wonderful concepts that are around that. And I'm really just excited to say that we, as Forte Group, get a chance to collaborate with them and what I call continuous learning and continuous delivering. So we are both learning all about Web3 and the concepts therein, while we're also delivering for them. So with that, I'm going to turn it over to Blane Sims, who's the head of product at Truebit.
Thanks, everyone. So we're here today to talk about Web3 and blockchain. So the first question I have to ask, who here has already tried using a blockchain in anything they've built? A couple? That's great. Thanks, Glenn. All right, next question. Who thinks that blockchains might be part of something important in your enterprise architecture in the next 5 years? Same, a little bit more? Okay, maybe 10 years? Anybody else? Well, I think we're here to try to help explain a little bit about what's been going on in the blockchain world, which is now kind of evolved into this concept called Web3, and hopefully demystify it a little bit. But the first thing we have to do in order to do that is take a step back. So we'd like to start thinking of Web3 and blockchains in terms of trust. First thing I say is welcome to the trustless world. This is a world where the current tools that we have to trust that information is true, is it real? Do we know where the information comes from? Do we know that we have the right to use it? The tools that we have to do that are starting to break. I think we saw that this morning with Alex's amazing presentation on AI. You can tell on the back of this image are kind of half a dozen human faces, or are they? These are all generated by AI. The New York Times did a really interesting article talking about the kind of this line that's starting to blur between things that we can tell are real and aren't. You see this over and over again, whether it's things as important as fabricated videos and political ads, or as trivial as fake songs showing up on Spotify that seem to be by real artists. This verge of change that we're on around AI, whether it's the singularity or not, I don't know, is really starting to take hold and will affect the systems that we build in our own businesses. So this might show up for us as an AI-powered customer service chatbot that starts to hallucinate. How do we actually protect against that? How do we accommodate that when more and more of our interactions with our customers are automated through AI? Or it might show up in terms of AI auto-generated code that we have to figure out how to secure, how to make run. But I'd like to argue that this trustless world has already been in existence for quite some time. Even though AI is changing everything, things like open source libraries, shared microservices, partner APIs, our need to deploy across multiple clouds, cloud-based architectures to begin with, all erode the control that we've had over our systems. So we're in a world right now, today, where we're relying on other people's code, other people's data, and other people's servers. And it really asks the question of who's in control of all of this. And it's only going to accelerate from here. And the risks are real. From a business perspective, if you think about this world of mashups, of shared infrastructure, of relying on someone else's code, Recent example of things that can go awry in your business. A couple months ago, Elon Musk takes over Twitter. One of the first things he does is pull the plug, to a certain extent, on the Twitter API. He started charging $42,000 a month for something that effectively was free before. Now you might go, what does that have to do with me? Well, if you had a customer service channel where you were accepting direct messages on Twitter, as many businesses did, and you didn't have $42,000 a month in your budget to pay for this, guess what? You're stuck having to pull that feature, and a lot of people are still working to pull that feature out of their channel. So something that you built on somebody else's stuff isn't necessarily always going to be there. Can you trust it? A couple years ago, Stripe had a 2-hour outage. All the businesses that use Stripe for payment processing, it's estimated, lost about $80 million in sale from one piece of shared infrastructure going offline. And even your entire business, if you follow the saga of Zynga and the phenomenon that was Farmville back in the day, they'd built a business that was 80% dependent on somebody else's platform. They put a lot of trust in that platform. Facebook changed their mind, and 80% of their revenue overnight was at risk. Now, thankfully, most of us haven't built our businesses completely on top of Facebook's platform, but in little ways, bit by bit, we're starting to get to this place where the things that we need to run our business every day are really dependent on things that we don't have control over. From a security standpoint, the risks are even greater. Don't know if you guys follow MITRE. MITRE is a cybersecurity think tank, partially funded by the government. And they've sounded an alarm in a recent paper about software supply chains. What is a software supply chain? It's where do you get your code from? What are the third-party libraries you're using? Are they open source? Are they from another commercial vendor? What code is going into the servers that you run? We've already seen a number of attacks, whether you followed SolarWinds a couple years ago, Avast before that, where foreign state actors actually use the software supply chain to hack into systems. We've seen Asus, the server manufacturer, have their firmware compromised. So even at the bare metal level, can you trust where something's running? And recently, about a year and a half ago, who here uses NPM? Thought so. Someone used NPM as a vector for a Trojan source attack on some front-end code. Basically, they put a perfectly benign front-end library up and then did an NPM update for that code and deployed the code into a front-end app, in this case, a wallet for a cryptocurrency, and ended up stealing $1.5 million of cryptocurrency before it was discovered. And all the while, the dev team that put that in place wasn't aware of what was going on. It's not just software supply chains. Coming back to AI, where we started the day today, we're only just now starting to understand how you can poison AI, how you can manipulate or create malicious uses of AI in the models themselves. In fact, there's a whole other conference going on this week in San Francisco, the IEEE Security Symposium, that's looking just at this. These are some of the topics from that talk. So it's pretty clear that we're going to need a new playbook. Especially when you think about the potential of every business user possibly using something like AI to generate code. They've gone out and solved the problem before they even come and talk to a dev team. How is that going to work? Or before that day comes, as we're relying more on applications composed from someone else's services, it's not enough just to try to hunker down and say, well, I'm going to keep a lid on this by vetting every single piece of code or every single library or all the data that I'm relying on. So what this is really about, as you take a step back from the code and look at the business issues that are driving this, is this world of interdependence. IDC, the research analyst firm, thinks that within the next 5 years, I don't know if I know about the timeline exactly or not, but we're on the verge of up to 80% of enterprises being part of an industry ecosystem, which is this interdependent set of connections between businesses, between business systems, that can only possibly work if their systems are distributed in a decentralized way. We'll talk about what that means a little bit during our panel. But this notion that it's not just my code that I have to worry about, it's someone else's is exploding. These ecosystems look different for each industry. In an industry like healthcare, it's about all of these different actors that never really worked well together, coming together through different connections. In auto, imagine over the next 10 years, We've got this almost forced evolution towards electric vehicles, also being kind of combined with the increasing connectedness of the car, bringing all of these different parties that need to have things operate into play together. This explosion of data that comes along with that, and probably any industry, for that matter, is in a similar boat where the need to create integrated experiences, integrated supply chains, value chains, is driving what McKinsey thinks will be $70 trillion of annual kind of economic impact from industry ecosystems moving forward. So what I'm here to tell you today is that the promise of Web3 and why I think in 5 to 10 years, everybody will be raising their hands about Web3 being an important part of their architecture, is that it provides a framework to actually build trust in code that you don't control. You might be saying, wait, what? I thought Web3 meant cryptocurrencies like Dogecoin and Bitcoin, or NFTs, or some of the early experiments in using public blockchains that have kind of been more hype than substance. And all that's true, but we like to think, at Truebit at least, of Web3 through the lens of compute. This is a little bit of a dated slide, but it actually kind of rings true today. This is Gartner from 2017 saying, hey, if you think about where is compute going, the world of compute as we know it today started to change. So we brought in hypervisors and virtualization, abstracting out kind of the server, the OS from the operating system. Containers brought that kind of step further, and now we're in the era of serverless, or at least starting to be in the era of serverless. If we think about this in terms of the applications that we built, that first era of on-premise compute made more efficient through virtualization was really the era of islands. Maybe call that Web 1, where we were just standing up our first business applications, first websites. The era that we're in right now of Web 2, of mashups and social media and all of the great applications that we have today was really enabled by containers and the cloud compute that's become so efficient based on that. And it's starting to really turn into this era. How many talks today were about how to really make distributed computing work for you, how to adopt different architectures, how to adopt things like serverless technology to make that happen. Our perspective is that this kind of latest distributed compute trend that we're in is actually what's going to allow this era of trust, this era of decentralization, of being able to not have to worry about pinpointing every piece of code that's running in your system, but having a mesh of trust around you. So we're going to need Web3. Web3 is, yes, partially built on blockchains. Blockchains are about creating a immutable store for records, but it's really more about shared governance, creating consensus across widely distributed systems. How do you know what's real? Verified compute, all of that distributed event coordination, the economics to run it all. How do you pay for all of this compute? And how do you ensure through cryptographic identity people are who they say they are, services are who they say they are? Leads me to Truebit. We've been around the Web3 world for a long time. We've really pioneered something called verified compute. What is verified compute? It's creating proof that this is the code that ran, proof that this compute actually executed properly, proof that the data coming out is related to the data going in. And we're starting to see verification really take hold in this concept of trust, where you need traceability for the data that you're using in an AI model, for example. Or you need to create a safe space for a shared application that you don't own, your partner doesn't own, some place for that to compute. And yes, back to the point of blockchains, blockchains don't really talk well to each other. They don't talk well to things that aren't blockchains. You need a verified kind of partner to help you connect that data in and out of those blockchains. So without further ado, I'll introduce the rest of the panel. I'm CJ Montano, CTO at Forte. Joined today as well by Jason Teutsch. He is the founder of Truebit, has done a lot of the seminal research around securing distributed compute systems and using game theory as part of that security strategy. And Federico Kattan. Fede is lead principal engineer at Forte, our core software architect on a lot of the things we're working on at Truebit. And myself, Blaine Sims, I head up product for Truebit. My background's in large-scale internet content delivery and e-marketing systems. All right. So Fede, I'll start with you. So this whole notion of Web3 and blockchains Kind of begs the question, what is Web3 and what are blockchains? Are they the same thing?
They're not. Hello, everybody, and thank you for being here. Thank you for the opportunity. Blockchain is really, they're not the same. Blockchain is a tool. You can think of a blockchain as a database. It's a ledger which has some properties different from databases that we used to work with. Is immutable, is replicated. And what that brings to the table is something that we built very differently in the past, which is trust. So trust is intrinsic to the data that is stored in the blockchain. And yes, we leave something behind like scalability or the ability to query with a SQL language or some formalized way of querying it. But we gain trust, and trust is a very special ingredient for many, many things. So what is Web3? Web3 is services, base services built on top of this decentralized view of data that has trust as a central focal point, and we build things differently in Web3. They have different properties that they will have otherwise.
So I just wanted to continue on Fede's point, but yeah, the blockchain is an important ingredient of Web3, even though it's not the whole thing. I mean, Blane also pointed out a slide with a whole bunch of pieces that has to be put together. But I think what I want to say is what makes the blockchain really special? What is it what are the characteristics or tools that the blockchain brings to the table? So I think, I mean, basically you can't disappear stuff, right? What is a blockchain? It's nothing more than a public ledger, or we could just say ledger, I guess. But usually say decentralized public ledger, which you can write to, but you don't erase from it. And so this gives us certain characteristics. For example, we have coordination, right? I mean, you can agree on that something actually happened. And separate from that is the provenance of that thing happening, which is that it's recorded onto the chain. So we have agreement on the record of the thing and the agreement that it happened. And then some of the other items that, ingredients that Blane already mentioned, like identity, yes. When you transact on Bitcoin or you transact on Ethereum, you automatically have a wallet address anyway because you're sending coins back and forth. So that cryptographic identity is already sort of built into the blockchain. Yeah, I guess since we're mentioning coins, there's also this economics aspect to it, which I think is also, that's something that's very native to the blockchain space. So that's...
Yeah, and that's where permissionless comes in. Permissionless, well, the fact that it's permissionless is because security is intrinsic to the data. And that's because of immutability and all the properties that Jason just mentioned. So that's how we don't need permission ahead of time to access something. We can read it, but we cannot delete it or change it or do anything with something that is already there. It's immutable.
And I guess I call it, the reason I hesitate when I say public ledger is because there's no reason why this technology couldn't be applied to a private network as well. You can, yes, you have, we've heard it, I know it sounds somewhat like an oxymoron when you say, private blockchain. It's a private public ledger, but, there are many different ways of sharing information. I think they're already out there. So anyway,
Well, CJ, I think you're a bit of a skeptic here. What's your POV?
Well, let me start by saying when I first got involved with Truebit, I had to go take Gary Gensler's MIT course on what is blockchain. Just to even understand the vernacular of it, it's challenging because my world, especially in a service firm, is I talk with CTOs and CPOs all day. And this is not at the tip of their tongue. It's not something that they're constantly thinking about because they're solving real world problems. And the more that I got involved with the technology or the concepts, I started thinking, well, hashing and encryption and Merkle trees and all of this, we have digital signatures. We have third-party certification services on the web. I was very skeptical. What is the point of this? If we have all of this already in Web 2, if we have encryption, if we have the ability to create hashing, what is the point of decentralizing this? We already have established trust in this third-party system. And so I'll kind of hand it back to you guys here. I know the answer now, but I'd like to maybe have you guys talk a little bit about that, because being more security first, I think, is very, very important, because otherwise it runs the risk of blockchain being seen as the world's slowest database or something like that, right? And you hear about it all the time. How do you establish trust? And then once you establish it, can it actually solve real world problems? And so I struggled with this because all of the concepts have been there for a long time, and they're sort of being used in a different way. So kind of what do you say to the naysayers who are like, we already have this. Why do we have to reinvent this? We just got to cloud computing and security and authentication through zero trust frameworks and stuff like that.
Well, I think you kind of answered your own question there, but because we have, building security in from the beginning. I mean, look, what an opportunity we have here in the Web3 world to sort of build it in from, that's the reason to use Web3 is because, yes, we are going to still use hash functions. They're not going to go away. But we have a whole new set of tools. And in fact, let me say that I maybe answered your question before you asked it as well. To go back to these 4 sort of technical pieces, what does maybe there's no Web3 without blockchain, which means that, you miss out on this sort of agreement over things that happened and sort of the, what I called coordination, what I called provenance. Identity economics. These are just more tools that we can put into the box to make things more secure. As we've seen, it's often a challenge to bring them in later, and often, it's not until something really bad happens that we start to worry about. You worry about security after there's a security breach. I think that happens pretty often.
So Jason, what I'm hearing is we have all these tools. These tools have all come together, and we can assemble them in a way that creates a blockchain. But what are the other things with these tools that are, this idea that blockchains and Web3 are one and the same is one of the things we're challenging today. What are some of the other things that you can do with these tools? What are we starting to see emerge now? Jason, Fede, what are things you're looking at?
Well, I think that anything that has relationship to compliance or to regulation or transparency is natural for Web3 or decentralization. You can export trust and transparency. Blockchain at the end is a machine to create trust. That's what it does. It creates trust instantly. So if you want to move to another vertical in your company and you don't have brand name recognition in that specific area, you can replace that with trust, instant trust coming from transparency, and the way that you provide services creates that sense of immutability or all the problems you mentioned, Blane, at the beginning.
And I just pick up from there. So if we think back to kind of the intro here, where we have these third-party APIs that we rely on today. Imagine being able to basically instantly onboard a new API partner, not to go through, if you're in a large organization especially, it can be a better part of a year of vetting security and vetting all of the technology that's underneath that. Having that trust built in, having just the assurance and then the proof behind the scenes that basically all of the code in their supply chain is verified and it's good to use. On all of the data that's being leveraged by their models, if they're an AI-based company, you understand the provenance. Where did it come from? It's these broader applications. The blockchain was the beginning, but how do we actually keep that trust moving forward, right?
Right, and that enables something very powerful that has been happening on blockchain for a long time, which is composability. You can, once you have a unit of work that is atomic and trustable, then you can compose that with something else.
Sometimes.
And that's very powerful. A lot of the protocols in blockchain work based on composability.
But I also think part of the opportunity here is to, going out, sometimes, we think security can be about going after the bad actors, which is a challenge. But if we can also come together and coordinate the good actors, which I think, some problems can be solved that we otherwise wouldn't be able to do as well. So I think there's sort of this, community has always sort of been, I guess, a tenet of the blockchain space. But in terms of security, it's really, I think, going to be another important component aside from the technical ones.
So CJ, what do you think about this notion that Web3 is an evolution for cloud computing, that this is the next step beyond the cloud where it's at today, which is stuck somewhere between containers and serverless compute, depending on who you talk to?
Yeah, I think that you and I had a good conversation about this about a week ago, but when I first started thinking about containers, Docker, that was sort of, I don't know if it was an aha moment for me because I was programming long before containers. But the concept of it works here locally, works on my computer, why doesn't it work on this environment? Containers largely solve that problem. And if you took sort of the natural progression there, I always saw it as sort of assurance that what you are actually building in your environment will actually work somewhere else by virtualizing the OS. We had VMs, we had, obviously now Docker has created that abstraction. As it moves forward, I really started to think of it more as utilization, a utilization issue, efficiency of compute power, right? You kept breaking down the servers into smaller and smaller containers. You had multi-tenancy, you shared, compute power, and that natural next inclination seemed to be Lambda, right? Function as a service, Azure Functions, whatever it may be. And that made sense to me from the perspective of utilization of resources and higher level abstraction of coding. But when I start to think of it from a decentralization, one of the things that occurs to me that might be very powerful and useful, and that I will certainly look into a little bit more, is Lambda, virtualization followed by containers, followed by Lambda and functions. Really, all is coming from the context of inside the cloud and utilization. Whereas fundamentally, if you start to think of decentralization as the Lambda or the function for the decentralization for the people, you are not locked in necessarily to that cloud vendor. And so, to me, that's exciting. But also I see it challenged with some of the performance issues and just kind of the manner in which it works being a security-first protocol. So I do see decentralization and sort of the higher level abstractions of coding being very natural, especially when you take into account things like you own your own data, you own your own code, so on and so forth. It's built into Web3 conceptually. And so that to me feels like it's a natural progression. But I'm wondering how that will actually play out in the world of, I know how to manage my cloud, I know how to reduce my costs through economies of scales, and vendor lock-in isn't that big of an issue yet. And so when is that bridge over to Web3 really, really necessary? That's kind of how I'm thinking of it today.
It's interesting, and I think, that's a pretty challenging point, right? So in the Web3 view of the world, really there are no servers per se, right? It's, even less serverless than serverless. You're not worrying about your code running on any specific machines. Your code exists in the universe, and whoever needs your code can call it. That's a pretty big gap between where we are today and the future. Fede, how do you see this playing out in the next 5+ years?
Well, it's not an all or nothing proposition. There's a happy middle point where you can have some components centralized and counterbalance that centralization with cryptography and decentralization. So you need to be smart where you put your components. Blockchain is a tool. And as a tool, it's not a silver bullet that is for everything. You need to be very specific where you use it and where you're not using it. The same way with databases or any other tool. And I think we are decentralizing things a long time ago. We're coming from mainframes into cloud, from internet at your desk to mobile internet, and now to edge computing and internet everywhere. So the progression, the trend is clear. REST APIs and the use of services from third companies and integrating those services into one service. These are all examples of some degree of decentralization. And I think that's going to continue on. and it's going to exacerbate. It's going to be more and more and more, especially with things like AI. It's going to be calling APIs based on context, based on what they're determining as context, or publishing their own APIs.
Yeah.
So I think that trust and verification needs to be an intrinsic property of APIs in the future. It's not a layer that we're going to be able to put on top of it. It needs to be intrinsic.
I think that point you made about AI is really, really interesting. Like one of the examples in the ChatGPT white paper is of a kind of a prompt that was given to ChatGPT 4, where basically the AI in answering the prompt, constructed its own API calls to, I think it was the Fiverr API, to go and actually get some of the answers from human beings, and was able, and this is the concerning thing, was able to actually trick the human beings, in terms of answering questions they had about what it was asking them to do, to go get that done. So that's kind of an extreme example, but you kind of pull that back in. I playing around with ChatGPT today, asked it to create an API call to the Google Maps API just to see what it would do. Perfectly constructed code, right? And that leap, that just small step forward of now someone else that's not a coder can make a business application run is kind of scary.
Yeah.
So Jason, we talked about Truebit and the work that you've done in particular, being about providing verification, and verification being this really core component to creating trust in a kind of trustless environment. What is verification?
I think verification, I would say it's things like certifying the integrity that something happened. So that the method of certification might depend on whether you're trying to certify it to yourself or to someone else. But when we're talking, I guess, specifically with respect to compute, it's about getting the confidence that something was done correctly. You should be as confident when someone else does the work as if you had done it yourself, basically. So, and if we think about, just as an example of proof, I can think of, in the 1980s, if someone showed you a Polaroid photo, you would say that's a proof, but I think if we have, 3 years from now, there won't be any proofs. And in fact, most of the images you see will probably be synthetic due to the AI revolution that's taking place. And so then what? Then what is your proof going to look like? I mean, it has to take, maybe a different form. And I mean, I guess it kind of goes without saying, generating these physical objects is a different challenge. I mean, making bits on an AI computer is just getting easier and easier, So it's going we're I guess you could say we're in a different era. We're always in a different era, but this is the era of verification. So.
And so you created Truebit to help scale blockchains. Again, blockchains notoriously slow. Single-digit kind of TPS is the reputation that they have. And you invented something that's come to be known as Truebit-style verification. What is that? At a simple level, what is Truebit-style verification?
So Truebit-style verification is a system where you would, if you have a way of resolving a dispute, if someone has brought a computation and someone else disagrees with it, then you appeal it to some sort of a judge who has some sort of restriction, may not be able to, for example, redo the whole computation themselves, but they can adjudicate whether the challenge is justified or not. So, yeah, I mean, in the case of what we have deployed on Ethereum, obviously the judge is the Ethereum miners. You can still call them that today. So those guys who run the smart contracts, the smart contract is the judge. The smart contract can't compute very much, but it's still able to resolve these disputes basically by chopping up the computation into tiny little pieces that it could actually verify. It's a binary search method. So that's usually what people mean by true.
And from there, the conversation involves lots of equations, which I can definitely go to Jason for. But I think what's interesting about this, so you invented this to help Ethereum scale, but when we're thinking about this as it applies to this problem of trust and compute, what we're basically saying is, again, imagine, today it's hard to think this, but as compute continues to become a bit of a commodity. Today the conversation is a lot was, hey, you don't have to use AWS. You could also use Google. You could also use Microsoft. Everybody's kind of offering the same things. Again, in that kind of not too distant world, it may not really matter which cloud service you use. You may not necessarily need a cloud service at all, as long as you know that the host that's going to run your job is running it correctly. And so what Truebit verification does there is it says, hey, I'm going to double check. I'm going to have more than one computer check this, and if they disagree, that's where this dispute resolution mechanism comes in.
I guess you could frame it in terms of the description of proofs. I mean, this is another form of proof. You're just having to prove it to a judge, whatever form that judge is going to take. I mean, whether it's to get your, in this case, economic rewards, or it's because you need to do it for some other security reasons. So anyway, I think it's a little bit broader than, it's certainly broader than the idea of smart contracts.
Right.
So that's it.
The thing that stands out to me is it's mathematically correct under the hood, and that's what actually helps create that trust where otherwise you don't have a basis for it.
And maybe you could do it with Polaroid photos. I didn't even think about that. But maybe so.
Yeah, that's another question. Well, let's bring it back to kind of the applications. Enterprise systems, the systems we build today, even when they're distributed, are really built around centralized architectures. What changes do you see in business, CJ, that are going to take us down a different path, maybe the Web3 path towards decentralized infrastructure?
Yeah, so I think it comes back to the core principles of kind of what you just define as Web3. So if you could get past this, we've already solved it, and really start to think about Web3 as its core principles. Now you can look at this as, well, the ecosystem is already set up for distribution, right? So it's because it's decentralized, now you have distributed compute. You have the world's largest distributed compute. And so same thing with data. You store data, it stores it in an encrypted and verifiable way. So you already have this ability to have ownership over your data. You have this ability to scale your compute. You have this ability to distribute in a fault-tolerant manner your data. I mean, as is like NFTs and how that works, right? And so you have all of this built into the construct. So if you could kind of get past the fact that the world doesn't have to be tied to a centralization like a SaaS product like Facebook or a cloud provider, now you could start to see Web3 as a more natural way to build software and compute it, and then it's endless. Then you get back into how do we get to low-code, no-code solutions? How do we abstract our development processes to focus more on what you're actually trying to accomplish in business versus reinventing the wheel about how are we going to verify this or authenticate that or create some provenance around something else. Like you had said, it's intrinsically built into this ecosystem. And that's what I'm most excited about this, because if the only problem is speed, but this world is set up for distribution and distributed power, I think that ultimately that's what we're going to see be the benefits of it as well, as soon as we could kind of figure out how to introduce that, or solve that speed problem. I see it as a more natural computing mechanism for the world.
And Fede, I think as we've talked about this, you see kind of these issues of trust, even within the same company sometimes in large organizations where composability is the kind of the name of the game. Tell us a little bit about that.
So yeah, I think as things move in the direction that always been moving, we're going to see these being used more broadly inside and outside of organizations. And our ability to distinguish bits is decreasing, as Jason just mentioned. It's easier to arrange bits in very intricate ways through AI or through some other means. And then provenance and verification becomes very important. And that's going to happen regardless of where you consume that data, if it's inside or outside of the organization. So to very recently, any of the persons you show at the beginning will require someone drawing on Photoshop or Illustrator, and that's time-consuming and expensive and slow. And now it takes seconds or milliseconds to produce thousands of those. So the ability to scale that arrangement of bits in very intricate ways is something that puts more emphasis into verification, into provenance. We need to know where things are coming from to make good use of them. Otherwise, they lose any value.
And Jason, do you think Web3's, since it's not known for scale, do you think it's part of the story of scale here in terms of distributed systems?
Well, I think Web3, yes. I mean, the story of blockchain is not about, speed or throughput necessarily, although those are challenges that people address. Although I do think it is about scaling, but it's a different kind of scaling. It's about scaling the composability and giving you, again, it comes back to security. How do I, given this mess of bits that keeps coming up in this conversation, how do we bring that back to an orderly place where we can find the information we need and have, it's a different kind of, we're not talking about like web browser security. We're talking about the situation of the way information is being processed. I mean, people have been crying fake news for the last few years, but the fact is, you put in the effort and you go out and find it, you can find what's true and you can find the information for yourself. I mean, when we fast forward 5 years, that may not be the case. Like, you may go out looking for it and you won't find it. You're going to need a new system of proof, I guess, is how I would say it. And that's what the road ahead, I guess. Then people will have a real reason to cry fake news because. So there you go.
Where do you think people are going to start, Fede? Like, as you start to think about Web3 creeping its way differently into the enterprise than we may have imagined in kind of the first round of hype around blockchains, what does it look like?
I did a quick mention. I think anything that's compliance or anything that needs to externalize trust, regulation, and vertical markets or adjacent markets to your company that you don't naturally have a brand name to back you up, you can replace that lack of recognition with trust and decentralization. Decentralization leads to trust naturally. That's why in the blockchain world, the cryptocurrencies are being still in the show, right? The fundamental ingredient for any currency is trust. So.
Yeah.
I also think, for me, as I've been looking at this problem, it's looking at the edge. To your point, not everything that we do is pushing the boundaries of trust to the degree that some of the things we talked about today might be, but some things are. I mean, to your point about regulation, I've done over the past few years myself a lot of work within the structure of GDPR. How do we become compliant? Mm-hmm. There's an entire section of GDPR that talks about a person's rights in Europe around automated decision making. And you think about the type of applications that the AI that's coming out now brings into case. Brings to bear. How would you, disclose how a decision was made where that type of AI is involved, or AI that you've already created in your own kind of system? So that's an example of the kind of those edge cases. The other place that I think is really interesting to your point is, again, this notion why I like the concept of these industry ecosystems that are forming. When you have an interdependence with some other company, like right now, it's really somebody's got a sponsored, or you need to go find a neutral third party to run a system for you. And I don't know if anybody's ever tried to create a consortium in business. It's not fun. It takes a long time, and there's always a lot of different things going on. This concept of trustless compute provides a neutral playing ground where some of those can start to bear. So absolutely. I really think, for me, we're just at the beginning of seeing the applications here, rather than kind of looking backward at what's been tried so far. Jason, did you have a point?
I was agreeing with you, but yeah, maybe we do want to jump to take some.
Yeah, we'll take some questions. Before I do that, I just want to say,
Sure.
first of all, or lastly, I should say, I really want to thank CJ and Forte for the opportunity to speak with everybody today. Obviously, we're, pushing things forward and at Truebit and expect to be talking a lot more in the future about Web3, but we couldn't really do it without folks at Forte. They've been just an invaluable partner for us to bring the expertise to light that's helping us kind of drive forward where we're going. So I really appreciate that. With that, take some questions if anyone has questions.
Thank you for the great presentation and very interesting discussion. So you talked a lot about advantages of Web3. I'm curious to hear your opinion on the biggest challenges that prevent Web3 to getting to mass adoption.
Who wants to take that one? Biggest challenges.
Well, I think scalability is one of the biggest challenges right now. The promise of Web3 cannot be realized if we don't engineer a way to scale a lot what we have today. So blockchains are clearly, as they stand right now, not enough for that future. And also some of the base services that needs to be built for Web3, storage, compute, identity, they still need to be built and receive more adoption.
The other one I add is this notion, because I talk to folks in the financial services space who are really excited because they actually see like the digital assets as being a great business opportunity, but they're held back by the notion that Web3 is really about public blockchains, about putting all of your data out potentially for the entire universe to see. That's a huge challenge. It's a misconception. We talked a little bit about this notion of private blockchains and the ability to have more more control over where your data is going, and I think people are just starting to see that's possible too.
I think you could say more generally, this obsession with decentralization is a barrier to the adoption of Web3 because it distracts us from, if you just say it has to be decentralized, you end up, and you push yourself back towards the blockchain, everything we've already created so far, and all of the sort of, I guess, restrictions that come along with it. What I think is needed to propel us into the Web3.
It's kind of all or nothing. Like if it's not entirely 100%
right. It's either got to be.
yeah.
It's either Web 2 and it's evil big data, or it's anyway. So or you have to, or it's all democratic and no. What we need. I mean, we focus on the value proposition, and what is the end goal? Yes, you actually can mix these two things together, and I think that's something. I don't know if I call it the barrier. I think it's more of an opportunity, but let's just put it that way. Yeah. So
maybe time for one more question. Anyone?
So I'm curious, what do you think is the role of homomorphic encryption in the blockchain? Do you see a future there, and do you see current barriers just due to the lack of accessible tooling in that area?
I might start. Actually,
go ahead.
I've worked with some early forms of secure multi-party compute, which is one of the applications for homomorphic encryption. Jason will be able to tell you more the math of how this all works. I think they're very complementary, to be honest with you. I think so. One of the things, going back to that notion of data privacy, that the blockchains in particular don't solve is, how do you avoid disclosing your data to another party that you need to share a shared compute job with, and I think that's where I'm kind of looking at some of the the innovations that are going around in multi-party compute in particular to provide that. I think the challenge, is the homomorphic encryption, the secure multi-party compute, really push the boundaries of compute power, and right now depending on how you do it, can take a fair amount of custom engineering. Every single type of thing you might want to compute in that way has to be kind of pre-thought. But I know that field's changing quickly as well. And on a related note, maybe after the panel's over, if you want to get Jason started on a related topic of zero knowledge proofs, I encourage you to come ask him that question.
I don't know that there's a mathematical answer to this question, so just a disclaimer, but you're welcome to come talk to me.